On deployment of simulated programs, as earlier shown, the robot is able to move forward, as you can see. Following that, where the ultrasonic sensor is placed is the front part of the robot. And on switching to the backward direction, you can see that the opposite side, where the ultrasonic sensors are not connected, is where the robot follows as the direction. And you can see that there are some issues where the robot does not follow a straight line due to the fact that some parameters have to be changed. Then onto the rotation of the left side, you can see that on the left side of the ultrasonic sensor is where the robot rotates towards. And this is done continuously every after a few seconds as per the program that is fed into the microcontroller. And as you can see, the robot is able to rotate. Then for the rotation on the right side, you can see that the right wheel to the ultrasonic sensor, following the earlier orientation for the front part of the robot, is where the robot tries to rotate towards, and then it stops every after a few seconds as written in the earlier simulated program before addition of the controller. Then to turn left, you can see that the robot follows a particular direction of turning, and it turns to the left side as well of the wheel, and it does not fast rotate it. Instead, both wheels turn at a certain velocity, and it follows this same orientation, and it starts and stops every after a few seconds, just like in the other orientations we had earlier for the direction. Yes, you can see that the robot moves, and then after it has stopped for a few minutes, it continues to turn left as indicated in the written programs. Then onto the robot movement to turn right, you can see that it takes a right turn after it's turned on. After the switch is turned on, it takes a right turn, moves, and then it stops. And after a few seconds, it repeats the same orientation due to the program that is fed onto the microcontroller. Both wheels are able to rotate. Both wheels are able to rotate towards the direction of the in-fed program in the simulated program. Come here. So testing of the robot movement with PID controller, with a PID controller. After fine tuning of the different parameters of a PID controller, we're able to come up with a KP value, which is 50, KI value, which is 0.01, and KD value, which is 0.01. KP is a proportional gain, KI is the integral gain, and KD is the differential gain. And as you can see, the robot is able to take a straight line moving forward with both wheels rotating forward. And considering that where the ultrasonic sensor is connected is the front part of the robot, for the backward movement, you're able to see that it takes the reverse direction, and it also takes on a straight line movement in the backward direction or reverse direction, with both wheels rotating at a particular speed as written in the simulated programs. Moving on to the rotate right, you're still able to see that the robot turns to the right side of the ultrasonic sensor, and this has a controlled motion due to the KI, KP, and KD values that are fed into the simulated programs. Onto the rotate left, you're still able to see that it rotates to the left side of the ultrasonic sensor, and it does this continuously due to the simulated program, and it can be turned off by pressing the stop button. Then onto the turn left, you're still able to see that both wheels rotate at a particular speed in a particular direction, and this is to the left side as well of the ultrasonic sensor, and it keeps doing this as well for some seconds as per the written program. And the same thing is followed for the turn right direction, where the robot as well is able to turn to the right side of the ultrasonic sensor, and it keeps this motion on as per the written program. And as you can see, it's more of a controlled motion due to the addition of the PID controller, which is able to give us different parameters to control. Thank you.